Hello, and a warm welcome to the webinar, Smart Parts, the AI Advantage in Predictive Parts Management for Field Service. My name is Paul Greenland, and I lead marketing at Brevity, and we're excited to sponsor today's event. Working with customers from across the service landscape to deploy AI, we've seen great outcomes from AI-driven automation and optimization. But one area that we find to be a consistent challenge is parts. We think of it as the last mile of service, because having the right parts to hand or not can make or break the whole resolution process. With that in mind, our agenda today will focus on the added value AI agents can bring to complement and enhance existing parts management technology. First, we will look at research and data and on the challenges and opportunities for predictive parts management. Then we'll cover how AI presents new opportunities to pinpoint and identify the right parts in that last mile. We'll cover a real-world deployment example. And for sure, we'll leave some time for questions at the end. So please do ask questions using the Q&A button at the bottom of your Zoom screen. So without further ado, I'd like to introduce and hand over to our speakers. Michael Blumberg is the president of Blumberg Advisory Group, recognized as an industry thought leader in service lifecycle management, field service, parts and reverse logistics. Michael has published hundreds of blogs, articles, white papers, and industry research, some of which he'll be sharing today. Gopi Kori is a senior technical architect at Brevity, where he leads development and deployment of AI models and solutions specifically focused on equipment support. Gopi has over 20 years experience in software and AI model development. So Michael, over to you.
Paul, thank you. I'm really delighted to be here to speak in front of our webinar audience today on this very important topic. It's the topic we were all faced with in field service, and I think most of us are aware of some of the problems and challenges, but I want to review them for you. And first one that we know from our research and our extensive work in the field service industry is that spare parts represents the largest investment and second biggest expense for a field service organization. And more than 50% of the time, depending on the organization, it could be anywhere from 50 to 65% of the time the technician is on site, they're going to need a spare part to complete that visit. However, what's has occurred because companies, particularly CFOs, are trying to minimize the capital expenditures on spares. They're asking field service organizations to be more effective in what they carry and limiting how many parts they have on hand. So as a result, what happens is that that only 60% of the parts are actually on that van or in the trunk of the field engineer. But let's add to that the 60% of the time the part is available. 20 to 30% of the times that a part is available is not the right part. So we can see just right out of the gate, we're running into some difficulties in the last mile and in improving our first time fix rate because of these parts challenges that we're encountering. So again, nothing new, but we've all been banging our heads against the wall trying to figure out how do we solve this challenge. Move on. So what often happens when it comes to identifying the right part? Now, I just want to provide some definitions here. We're using the term parts prediction, but what we really mean is parts identification, knowing that when you're in the middle of a service event, you're in the throes of a problem resolution scenario, to know exactly which part, not just what category of part or what type of part, but the exact part number, the exact make and model and version of that part. That's different from another term that people often will refer to or confuse what I'm talking about with parts forecasting. So sometimes companies refer to parts forecasting as part prediction. Here we're using the term parts prediction to be effective, accurate identification of what part to take. Now, there are often reasons why we're running into challenges with identifying which part to utilize. One of the reasons is guessing. The field engineer just guesses at what the part is. They might do what we often call, and many of us use this term, phone a friend. In other words, they phone a mentor, a colleague, somebody else is in the field who may have seen a similar situation, and they ask them what part to use. They could go out on a site, not know what part to take multiple parts on their van, but neither one of those parts is the right part. Even if one is the right part, you're still tying up that other part. You can't be using it anywhere else. This next term, polling, another word for that is using the part, or another term for that is using the part as test equipment, where the technician is pulling and replacing various versions of the same similar part and figure out which part is working is the right part to utilize. They could rely on historical data, like what have they seen before, or they could be accessing their field service management system database to find out are there any other problems like this when a problem was encountered, what spare part was utilized. But all these different practices have some risk to them. For example, the parts remain in the field engineer's trunk or van. As a result, they're not being utilized and it's tying up capital. There might be lack of visibility to inventory because of this. Because the truck part is in the truck, nobody knows where it is, or nobody knows how much of it is out there, or the valuation has become unclear because all these problems, all these shortcomings in identifying parts using what I'm calling brute force. All these examples are brute force, using your experience or what you perceive to be your own knowledge to solve the problem versus using advanced tools like AI, which we're going to talk about how they work during this presentation. Let's move on. So more performance metrics and benchmark data here. We're looking at laggards in the industry. These are companies in our database that they're in the bottom 20% of the companies. Then we have the average and the median, and then we have the best in class, which is the top 20%. So the ability to accurately identify what part to utilize to solve a problem directly impacts all these parameters. For example, investment in spare parts is a percentage of aftermarket service revenue. You can see that companies that are more effective in managing their parts, which includes forecasting and planning the parts, having it at the right location, and last but not least is knowing what part to use. They have a 20% versus a 30% among the laggards. Investment in spare parts is a percentage of the installed base. Much lower investment in spare parts when you're doing a more effective job in planning and utilizing the parts. 1% versus 7% for laggard, 5% for industry average. Turnover also increases significantly. If you're more effective in identifying what part to utilize, you're going to turn all your parts over more quickly. We've got some other very important metrics that you're all familiar with, like trunk stock fill rate, first time fix rate, inventory carrying costs, service level compliance. They all show improvement when a field service organization is doing a more effective job in managing spare parts. Lack of a pun, but a term my late father, who was my mentor in the field service business, a consultant himself, used to say, "You're operating on all cylinders." Another spare part, but when we're doing an effective job of managing spare parts, we're operating on all cylinders and achieving better KPIs. Let's move on. So when our ability to have the right parts on hand and select and utilize the right part is going to improve the number of service visits per service event. On average, field service organizations experience between a 1.3 to 1.5 service visits per service event. So that means every 2 service visits, there's 3 visits a technician has to make. But that's just for basic equipment. But when you're dealing with more complex equipment, you're going to see higher visits, more visits per service event. So if you're dealing with a piece of equipment that's not only complex, but there's only 1 or 2 of them, right? Because they're highly configured as well, you're going to have very high visits per service event. And the result of that is multiple part shipments and transportation legs, which in turn impacts operating expenses and has an impact on the environment, more in emissions, more waste, etc. And also a lower call completion rate results in reduced field service productivity. They're not completing as many calls per day because they just don't have the part to solve the issue. They have to come back, or they have to leave the call open or abandoned because they don't have the right part. And indeed, spare parts identification remains one of the largest challenges to achieving a high first-time fix rate. In fact, there's been some recent studies out there, I think it's by Gartner or IDC, showing that we're using basic diagnostics to improve the ability to identify the problem and determine the corrective action. At best, that could lead to an 85 to 80% first-time fix rate. It's that additional ability to predict what part, identify what part is going to result in even higher first-time fix rate. So that's why this is so important. So 3 to 5% improvement may not seem like a lot, but it really is when you think about the cost to the service organization, excuse me, and the impact to the customer of not having the right part on hand. Let's move to the next slide. So let's kind of unpack this a little bit more. Here's an example. It's actually something that's actually happened to me. In my home, I have a new home, and I also had a new dishwashing machine that I purchased. And one day it stopped working. So I called the appliance dealer, who the manufacturer suggested I work with, and I reported the issue. Well, I think what happened was the technician, based on the issue I gave, took a guess at what part he might need. He went out on his truck, or his van in this case, came to my house, installed the part. It worked fine for about a half an hour, and then he left and it stopped working again. So I had to call again. He had to make another trip out. Again, it failed. And on that second attempt that failed, he realized the part was right, but there was another part that he needed to work in conjunction with the part that was replaced. So he had to replace two parts, not one part. So that ended up in the third truck roll for him to come out with the correct part. Now, because of this situation, I couldn't wash my dishes. I had to wash them by hand. And to me, that was costly. Might say, well, it's your own time. Well, my time is valuable. All right. So it costs me money. It costs me my time. And also, I was getting to the point that if he couldn't fix it on a third event, for sure I was going to replace that equipment, that dishwashing machine, with another brand. So he could have lost me as a customer if they continue to have this problem, not identifying what part to take. So let's move to the next slide. So let's examine the financial impact of this scenario. So let me pivot to kind of general industry scenario. Before I was talking about home appliances, but now I'm talking about any kind of complex capital equipment. And so on average, labor costs for a field engineer is on average $300 per truck roll. In the example I gave you, there were 3 truck rolls. That's $900 that was spent right on the get-go. Second cost is the transportation cost, the wear and tear on the van, and mileage, and the gasoline, and all that averages about $100 per truck roll. So now we're at $1,200. Then there's a parts cost. There's a $200 that was spent on that inaccurate part. That part was tied up, couldn't be used anywhere else. That was costing the company $200. And then the company had to expedite a spare part, okay? And that was an upcharge for that, another $300. So now we're into it for $1,700, right? So it's adding up. Just that one event, because the part wasn't there, it's costing $1,700. Then now let's pivot to more of an industrial setting, where that estimated downtime might cost $5,000 in total of all the hours spent. Maybe that's kind of conservative for manufacturing, because in my situation it was about a week I was down. So who knows? Maybe we're talking about tens of thousands of dollars, hundreds of thousands of dollars. But then there's also the customer retention risk, where the customer may leave. They may no longer get service from the company, may go to a third party, or they may just replace the equipment. And here I'm using a very conservative figure of $20,000 for that customer retention risk. So the total of all that, when we add it up, the total direct costs of having the wrong part and missing the first time fixed target is $1,700 per event, plus another $25,000 of indirect costs from the downtime and potential revenue loss, for a grand total of $26,700. Again, not just for one event. So let's say you have every technician experiences that at least one time a day, and you have 1,000 technicians on your team, and you're doing this every day, 365 days a year, you could see that the numbers of dollars, euros, whatever currency you're in, adds up pretty quickly and pretty significantly. Let's move on. So there's a number of reasons that parts prediction is challenging when we're trying to do this based on brute force. Again, brute force meaning our knowledge, our experience, chipping away at the problem. There's a couple of them I've identified. I'm just going to zero in on a couple that I think are the most interesting to me, and maybe for you folks as well. Parts equipment complexity. That might result in it having a problem in predicting a part. You might have a piece of equipment with multiple components or multiple configurations, so the parts may differ from configuration to configuration. Machine may look the same, may perform the same activity, but the part is different. Another one is human factors. If you're guessing, you may not have the right expertise, experience, or the ability to handle all the knowledge you've developed over your lifetime of working to know what the right solution is. Other ones are extensive parts catalog and databases. You might be dealing with a company that has a very large installed base, large inventories, information is unclear, so it's hard to know what part. And then very closely matched that is documentation knowledge management, where the part might have changed through an engineering design change, or the manual may be based on the as built BOM, and since it's been in operation, there's been a number of changes or replacements to that BOM with a service BOM, and maybe that information is inaccurate. Maybe it exists somewhere, but person's knowledge carrying around a manual to look it up in the field to figure out what part they need just isn't accurate. So I've hit a couple of these points. So let's move on to the next slide. So want to talk a little bit about the evolution of the technology that's available to field service organizations to help them with their parts management. So if we go back to the 1980s and even before, the way companies identified what part to utilize was by sending a technician on site and doing some troubleshooting and saying, aha, this is the part I think I need, right? And indeed, there's still some companies that operate this way. Then around the 80s, 90s, when I started my career in 1985 in field service as a management consultant, companies were using basic databases and inventory management systems. Maybe they're using their a computerized maintenance management system, or maybe they're using MRP2, for those of you who are around long enough to remember that. And then around the 1990s, 2000 timeframe, we really started to see the emergence and, more importantly, the proliferation of field service management software, ERP, computerized maintenance systems, and workforce management systems, and warehouse management systems. And what that basically allowed companies to do is to track what parts they had on hand and what parts were utilized. So data was becoming more available, but it was time consuming to find the right answer. Okay. And then around the 2000, 2010 timeframe, FSM and field service management and ERP systems became more advanced. We saw the addition of knowledge databases, knowledge management systems to look up based on the problem or the symptom to look up what the solution might be. We saw the use of barcode scanning, where a technician could scan a label on the part, and that would identify what part to replace it with. Then around the 2010, 2020 timeframe, the emergence of remote monitoring, telemetry, and IoT, giving us more data, give us more information to help us diagnose and troubleshoot and identify what part. And now here we are today and beyond, we're seeing how artificial intelligence, machine learning, chat GPT, augmented reality, and digital twins are helping us become more accurate and more precise in our ability to identify what spare part to utilize to solve a service issue. Next slide, please. So, there's a lot of choices that field service organizations have and field service leaders have when it comes to implementing software to help them manage their spare parts. So I wanted to identify some of the major categories and kind of compare and contrast them here. So we have ERP vendors like SAP, Oracle, Microsoft Dynamics. And if we just talk about the kind of the basic ERP, not some of the advancements we've seen in recent years, uh, when it comes to troubleshooting and diagnosing service activity, service events, if these solutions provide basic search and lookup, and they often are integrated with other systems to provide more advanced capabilities like troubleshooting or dispatch, so on and so forth. And when it comes to spare parts, I view them as having limited capabilities in identifying and predicting what part to use. It has management capabilities, spare parts management capabilities, but not very robust when it comes to predicting what part to pull off the shelf to solve a problem. And any data it does have, it's based on historical data, what was used in the past. So my overall assessment is it's got limited real-time data and it lacks advanced predictive analytics. Then we have field service management software that's been available for some time. We have ServiceMax, IFS, Salesforce Field Service. It's more advanced than ERP. My opinion on this is that it focuses mostly on triage, trying to identify what the problem could be and prioritizing it, and doing some basic problem symptom resolution when it comes to spare parts. But it requires diligent data entry. You got to be very thorough and precise in what data you enter into these systems in order to get the right answer when you're going through a query. And it can be complex to integrate and may lack special analytics. And one of the things I want to mention that all these software create ecosystems, create an ecosystem, and some of you may be on these platforms and ecosystems, but there's advancements all the time in these applications. And let me continue and try to shed some light on that. Then we have enterprise asset management and computer maintenance management software. And these are offered by companies like IBM, Maximo, Infor, Fix. They're mostly focused on plant management. So to me, it's like an ERP, maybe it's some oversimplification, but an ERP for plant maintenance. And it's good at looking up what part is needed. Doesn't tell you, it's not accurate, just says you need this part. But the prediction capabilities are limited, as I was just saying. And it's focused on maintenance and less focused on parts prediction. Then we have another category, slightly different, and that's supply chain management and spare parts optimization. And that's offered from companies like PTC, Baxter Planning, and Synchron. And that's focused on inventory optimization, making sure you have enough parts and they're at the right location so you can achieve a higher first-time fix rate and improve performance in other metrics. But it's not necessarily helping you predict the exact part to take, just that you need this type of part, and this is where you should have the parts, and this is how many you should have on hand. And then lastly, we have AI and ML solutions, such as those offered by Brevity. And that offers advanced capabilities that leverages AI and real-time data and also provides advanced predictive analytics, resulting in higher accuracy. Now, the point of all this, I want to underscore, is you don't have to throw anything out, okay? Just because you like a solution provider with AI and ML, like Brevity, you don't have to replace your ERP or FSM with anything else. You can simply add it on. Maybe an oversimplification, but you can add it on. And I'm sure Brevity will talk to you about what's involved in adding it on. But that's the point. You don't have to throw anything away, toss anything out. You could build upon what you have by adding a purpose-built solution for parts prediction. Let's continue. So let's look at the impact of parts prediction, diagnostic software, and KPI. So far, let's review where we are. We talked about the problem. We talked about the cost of the problem. We talked about why we have the problem. We started talking about the solutions and how AI can solve the problem. Now let's look at what the actual results are in this slide. So first of all, there's a cost reduction and operating efficiency that's achievable through using parts prediction software. For example, it results in reduced repeat visits, lower inventory costs, and decreased downtime. And that leads to happier customers, lower downtime, less repeat visits. They're getting the calls resolved quicker. So that leads in turn to higher customer loyalty because the resolution times are higher. So that's achievable. Because the resolution times are higher, there's an improved reliability and trust the customers have with the provider. It also leads to a higher NPS score. And studies by Gartner show that for every 7-point increase in NPS score, there's a one point increase in revenue. So if you're a $1 billion company and you're going from, let's say, a 45 NPS score to 52 NPS score, you're going to increase your revenue by $100 million. That's not too shabby, I think. Let's move on. So now let's look at our data, what the data shows. Data backs this up that for every 10% increase in first-time fix rate, there's a reduction of 33% reduction in costs. And so in a way, it's exponential improvement on costs by utilizing this kind of software. And next slide. And there's more of a one-to-one improvement on NPS. For every 1% increase in first-time fix rate, there's a 1% increase in NPS. Now, you might be thinking to yourselves, well, this AI stuff seems pretty neat. It's pretty cool. I'm using it myself. Maybe we should build this internally on our own. And you may even have in your company, you may have a chief AI officer, or you're thinking about one, and your board or your CEO is saying we need to have an AI strategy. And that's all great. However, there's a lot involved in trying to build a solution like this on your own. There's the time and the cost. The reason why there's a time and cost because you need some competencies to do this accurately and effectively. So of course you have to have software development skills. You have to know how to build, have experience in building software like this. You need to have expertise in data science and machine learning, in data engineering, in IoT and real-time data monitoring, in natural language processing, and then you have to have the domain knowledge of spare parts. So it might take years and years to build up this capability where you can turn to a company that's already been doing this for years. And that's how you find an optimal AI-enabled solution when you turn to a business partner that has all these skills and competencies. Next slide, please. So with that, I want to turn this over to Gopi, who could discuss with you how Brevity is impacting the spare parts prediction process.
Thanks, Michael. Okay, so now we will go through a real life use case with one of our deployments. And this particular deployment that we are looking at was with one of the home appliances, large OEM. And initially we started with sizing of this particular opportunity and identifying the strategy and the whole deployment planning. Looking at the numbers once this was deployed. So what you see on the screen is the results of our parts prediction model from the 4 months into the deployment. So this table details out about each type of appliance, but let's just focus on the last row, which shows a combined result of everything included for all the appliance types. So during the 4 months, we see that the call volume is about 400K. So about 400K calls are coming into the call center for various kind of customer issues in this particular OEM. And we realize that not all of them are something that we need to do parts prediction. For example, the customers keep calling for just checking the warranty status or just for asking for some user guide or documentation, etc. So there we don't need the parts prediction. So we can ignore these kind of calls. And now we have the calls which really need parts prediction, which are about 74%. Again, there is next level filter where not every customer goes with the service. So some customers may just deny service or cancel, or they don't want to do service. So excluding all those calls, then we are left with about 200K calls for this 4 months. where we actually did use our parts prediction, and at the end of 4 months, we compared with the after the fact results. So whatever predictions we did, whether those parts were really used or not in the field to fix that particular problem. And it turned out that about 170K of those records where we were able to do the accurate predictions for. So that turns to be about 80% of those calls. So starting with a deployment at this scale and getting to the accuracy of 80%, it was a good achievement. But I'm going to explain in the next slide that getting to this 80% involves a lot of things. And we'll go into more details on this slide. So in this particular case, we had started with our initial version, which we call as 0.1, and it just started with our basic model setup, and we saw an accuracy of like 50%, like 0.52%. And this is a very low, obviously, to start with. But then this particular parts prediction model, it is kind of an iterative process where you need to define certain parameters, fine tune it, and do multiple deployments, fix those things, and do some kind of hyperparameter tuning. And it can take some time to do these things. But what we have done here is we used our parts prediction AI agent that we have developed that can quickly iterate through all of these iterations and accelerate this process to get it done faster, to get at a higher accuracy. So the version 0.1 to 1.1 was accelerated by using our parts AI agent, and that does various things that I'm going to explain now. So for example, after the initial deployment with this very primitive accuracy of 50%, then the next step that was done was doing a data cleanup. So data cleanup is something very important because not all the data is always clean. Typically, these parts prediction models are trained on your historical data, such as service records or part claims, warranty claims data. So, and all of that data can have a lot of noise, inaccuracies, unnecessary text, random system text, some domain specific abbreviations. So all of that cleanup needs to be done. And this is a particular step that our AI identified, and that added an accuracy of, that took us to an accuracy of about 58%. Then we realized that that data had many other inputs that we need to consider for doing those predictions. So for example, there were some error codes in certain cases. When those are combined with the information from the service bulletins, that can give you some valuable insights in terms of what parts need to be used. So that took the accuracy to a little higher level, to 61%. The next step is about using the right kind of prediction AI models. So Brewity's AI model is basically, it's a combination, or it's an ensemble of multiple models. We typically call it as a mixture of experts. So every model has its own capability of doing better parts prediction in a certain case or in a certain scenario. So we have these n number of models, and they work hand in hand to identify for a particular case what are the parts needed, and the ensemble approach takes the best result out of each based on the input conditions. And these models are various industry standard models plus our proprietary models. For example, uh, those are the complex neural network based models. Plus recently we have added LLM based models, and there is also a part of rule based models and many other ones. So the result is basically a combination of output from all of these models combined together, giving them different weights and getting the perfect result out of it. So that's how we could get to an accuracy of about 70%. And this was good enough, but definitely not good enough. There are more things to do. So the next step that was identified was to filter out calls with insufficient inputs. So we realized that the incoming data, because it came from various legacy systems over last many years, it did have certain gaps. So there were some missing fields and those things. Basically, if you train your AI models on incorrect data or insufficient data, is going to deliver the similar results. So it's important to filter that out. So that was the next step that improved some results. There are also some vague data descriptions in the input. For example, a consumer complaint can just say not working and no more details than that. And this doesn't help the AI to learn anything from that. So these kind of inputs, we have AI models that basically from the input identify what is vague and what is clear, and whether we should use a particular input for training our AI. And after doing that, then that's when we could get to an accuracy of 80%. And all of these steps were followed to get higher accuracy. Okay, next slide, please. Okay, so all this is great, and now we had a parts prediction engine working, but it's important to note that it need not always be an additional system on top of your existing systems, because there are call center agents and the field technicians and all the stakeholders who may be already acquainted with many of these ERPs, CRMs they are already using, and it can be an overhead to use yet another system on top of it. So uh, this parts prediction engine that we provide is kind of a plugin that can work with all of these systems. So when we think about part prediction, it learns based on your historical data. So it needs to have access to your warranty data, history data, what parts were used in the past. And when it does this, it also needs information from your parts catalogs and BOM data, which is the knowledge base. And when the output is generated, when we predict the part, it has to go into the right place so that those are used by the right people to make sure that those parts are available in the truck before it's sent out. So this information that is generated, the parts prediction, it needs to go back into the systems like CRMs or ERPs. And in this particular deployment, the OEM was using Salesforce. So the data that we consumed was from Salesforce, and the results generated were pushed back into Salesforce. We also had our parts prediction widget integrated into the Salesforce so that the agents uh, didn't have to learn to use a new system. Our widget just integrated seamlessly within that Salesforce UI. So it was a very seamless experience for the agents who were using it. Next slide, please. Okay, so this is just a glimpse into how it looked. So this is a particular Salesforce case. When an agent is talking to the customer, he's using Salesforce to refer to a different knowledge base and take the details of the case, the issues, so capture the problem description. And our parts prediction widget was embedded into this screen. So this parts prediction widget had access to all the historical data for this particular model, for this particular equipment, serial number, and then it can generate the parts prediction based on all the data available, including the problem description. And all of this is happening even without the agent having not much knowledge about parts, because it's just capturing the information from the problem description. It's using all of the historical knowledge that we had trained our model based on, and it's generating these results. Those are written back into the same case so that those parts are carried on the truck. So all is happening without even agents knowing into the details of it. Next slide, please. Okay, so a vague description, as I mentioned, can always lead to an incorrect parts prediction. So it's important to have the correct details for a particular problem. And this is where our parts prediction engine helps. So if, for example, a customer says it's leaking, you may not be able to predict a correct part. You need to ask the right questions. For example, where is it leaking from, front or rear? What is it leaking? Is it water or oil? So these qualifying questions are the important ones that need to be asked to the customer, so that you know that what is the real issue and the parts prediction gets better. So we have this integrated triage bot into the parts prediction engine that helps the agent to ask the right question to the customer, capture the correct knowledge, and do the better predictions with higher accuracy. And this also leads to another advantage of as we capture more data from the customers, we have detailed problem descriptions. And in future, as this data set has more and more details about the problem, the models is periodically retrained on the same data. And because of these more details, its accuracy gets better and better over time. Next slide, please. Okay, so if you are interested into getting into more details of this case study, here is a link that you can hit, and surely you will find definitely more details about this particular use case there. Yeah, thanks, Paul and Michael. Handing over to Michael.
Thanks, Kopi. So let's kind of look at some of the takeaways of what we discussed today. I think the first thing that hopefully we'll all walk away from here is an agreement that field service organizations have plateaued in improving first-time fix rate through traditional methods. We really need now to go to the last mile, which is improving the accuracy of spare parts prediction. And AI and ML can handle that effectively because it can deal with the vast array of data that's needed to accurately predict spare parts. And these solutions, they can be integrated to existing field service management software platforms. You don't have to throw anything out. We just can add it on. And then I think I've demonstrated to you that accurate parts identification saves on labor, transportation, and parts costs, while at the same time optimizing inventory levels and lowering costs and also achieving greater levels of sustainability through a reduced carbon footprint and its impact on other environmental factors that impact service operations. So hope you found today's webinar valuable. I think now we're going to open up the floor for questions. And by the way, this is how you can get in touch with us.
Thanks, Michael. Yeah, we got a few questions coming in, so thanks for those. The first one I got, I guess it's probably for you, Gopi, is the implementation that you showed, the parts prediction implementation. How long did it take to get that up and running? What was the timeline?
All right. Okay. So the timeline typically varies based on the case and scenario, but in this particular deployment, as I mentioned, we initially sized this particular opportunity, and it took about 2 weeks to get to the initial model, and then further few weeks until we got it tuned and did a final deployment. And after that, the results that that we shared were captured.
Okay.
Yeah,
Thanks.
took for an initial model and then further
Okay.
some thing for a few weeks.
So about a month out the gate kind of thing.
1 month or less than that, right?
All right. And then I guess, Michael, this looks like you referenced a few things, parts management, parts prediction, parts identification. Could you recap on the differences?
Sure. So parts management is making sure you have enough parts, sometimes at the right places. Then there's parts planning and forecasting that allows you to get those parts at the right places. Then we have parts prediction, which in this presentation, I'm also interchanging it with parts identification, which is ensuring that you're very as precise and accurate as you can be in identifying what part to utilize to solve a service issue. That's parts prediction.
Okay. All right. So I guess what, just to jump on that, you can predict the parts that you might need, but then you've got to identify which one of those parts you need to actually take to fix the issue. So it's kind
Exactly.
of
Exactly.
Okay, I got it.
So, and you might have to get very nuanced and very precise, like what version of the part you need.
Yeah. Okay. What in the Michael, I guess it's for you, like the question is, in the next 3 to 5 years, what areas of parts management do you see AI capabilities developing further and adding further value?
There's two things that I see. One is this technology will be utilized in a customer self-help scenarios, particularly as we're seeing the push towards right to repair. So we're going to want to allow our customers to utilize it. Also helps us improve the customer experience and reduce our costs if we can push some of the work back on our customers to take care of it. They want to do that because they can get immersed in the experience, and it creates a better experience for them when they do that. And the other thing I see happening is, and it's currently happening right now, is a convergence of augmented reality, visual guidance with these types of tools and technology.
Yeah. Just to add to that, wanted to highlight that Brevity also has the vision AI models, and recently we are using it for some of our customers to identify the parts and even identify some broken parts.
That's great.
That's great. Thanks. Okay, I think we're coming up on time here, so we've got one last one to squeeze in. The example showed, the deployment showed was the UI was in Salesforce. Does it work with other service platforms?
Yeah, it does. So it does work with many other service platforms, contact center softwares, ERPs, CRMs, and importantly, it can work independently on its own as well. If you do not want to do any integration, it can have its own UI. It can integrate in the form of APIs, reading and pushing back the information into these systems. And if these systems provide a UI interface, then we can also embed the parts prediction widget within those UIs. So there are multiple integration approaches that we follow.
Okay. That's great. Thanks, Gopi. Well, look, that concludes our webinar for today. Thank you to the speakers, Michael and Gopi. I hope you found it informative. The contact details are here, and we will be sending out a replay of the webinar in the next couple of days. So look forward to that. And again, thank you for your time, and have a good day.
Thank you.
Thank you. Bye, everyone.